Hi there. I am just going to briefly step you through how to do assignment 4. First, let me remind you that we have been talking about tuning, and tuning has 3 stages. In the first stage, we decide what is the optimal setting for a parameter, and we do this by doing a cross-validation over the cross-validation set for each possible setting. Then we look at which of those cross-validations gave us the best performance, and whatever setting we used in that cross-validation is the one that we decide is the optimal setting. Then what we're going to do is train a model over the whole cross-validation set, and the setting that we're going to use is the one that we picked in stage 1. Then in stage 3, we're going to estimate what we think is the performance of that model. We're not measuring its performance, but what we're doing is we're estimating what we think it would be. And we do that by doing a cross-validation in which on every fold, we do stages 1 and 2 on the training data, and then take the resulting model and apply it to the test data on that fold. We do that for each fold, and we average across folds. So it's very much like the standard idea of cross-validation we've been talking about all along, but it's a little bit more complicated because it has an inner loop. So in this demonstration, I'm going to use SMO, which is a Weka version of support vector machines, to walk you through the process that you're going to do on assignment 4. When you do it on assignment 4, you're going to do it twice, once for a classification data set and once for a regression data set. And okay, so what I'm going to show you though is for SMO, which is a classification algorithm. And what I'm going to show you is how would you do stage 1 in the experimenter, and you do that by loading in the whole data set, and then you're going to do cross-validations over it, and you'll see where that happens. Now in stage 2, we know that we would build that model, but we're not actually going to build the whole model in this demonstration, but we assume that once we know from stage 1 what the optimal setting is, we could do that in the Explorer. Then we're going to do stage 3, and you'll see that you load different files for stage 3 in the experimenter and run a very similar experiment. But then you have to go and do the final part of stage 3 in the Explorer, and I'll step you through that. So here's the experimenter, and I'm going to show you now how you're going to use this in the assignment. You can see here in the front panel of the experimenter as it's displayed, on the left-hand side we have data sets, and what we have is for a particular data set, when you open up the folders for the 2 data sets, in each one of those folders, you're going to have 11 files. One of them is the whole data set, and then 5 of them are training sets, 1 per fold, and then the other 5 are testing sets, 1 per fold. But in the experimenter, you're only ever going to use the cross-validation set and the 5 training sets, and you load them on the left side of the front panel that's labeled as data sets. And note here, because this is a classification data set, we have this radio button set to classification. On the right-hand side, we add in the 3 versions of the algorithm. So we've added SMO 3 times, and we add algorithms each time using this Add New button, and then there's a Choose button, and then we configure the parameter setting. We're going to be looking at exponent, as I said. So when you load in SMO, so you choose it by clicking on the Choose button, you pick SMO, and then you're going to look at the polynomial kernel insert, and then in that, the object editor for the polynomial kernel, you can set the exponent. So you'll do that 3 times. On this display that you see here, you can actually see where the exponents are showing. You can see that for these 3 times that I loaded SMO, each time I put in a different exponent. Another thing I'd like to note is that I changed the number of repetitions from 10, which was the default, to 1. And as I've mentioned in a previous lecture, that's what you want to do. So let's just quickly review all the things that you have to set on this front panel. You want to make sure it's set to simple. You want to make sure the repetitions is set to 1. You want to make sure that you've selected classification or regression depending upon what kind of experiment you want to run. Then you're going to load 6 files, and one of which is the full set and the other 5 of which are training sets. And then you're going to put in the 3 versions of the algorithm. Then you're going to go to the run panel and you're going to run it. And then you're going to go to the analyze panel. On the analyze panel, there's a few things you have to set too. The most important thing is column and row, which you see over here. Columns are the algorithm with its settings. And so for column, when you click select, one of the options is called scheme. You're going to want to pick that one because scheme is algorithm plus settings. And you want to make sure that it sees the differences between those settings. And for row, you can see the rows are the data sets. So when you click on the select button by row, pick data set. Then you're going to pick the comparison field. Here you see % correct. The assignment probably tells you which one to use. Usually I ask people to use kappa. You could use kappa or % correct. It doesn't matter that much. Okay, then to run the test, you're going to click perform test, and that's where you'll get this table that you see here. Now, if you look at the first row, what you see are performance values for cross-validation of each one of our 3 algorithms, and you can see them in the order that they're listed down below here. So 1, 2, and 3 correspond to exponent 1, 2, 3, and so 1, 2, and 3 are exponent 1, 2, and 3. The first row is the whole cross-validation set, and the performance values in terms of % correct are 61.22, 62.92, and 66.39. So we know that for stage 1, we want to do a cross-validation over the whole cross-validation set once for each one of our settings, and we've done that. And we can see that exponent 3 is the best one. So that's the answer that comes out of fold 1. Exponent 3 is best. So we know when we build our model, it's going to be with exponent 3, but we need to do stage 3 in order to compute the performance estimate. So in stage 3, that's what the table that you see below is for. We're going to fill in this table from what we see in most of the table in the experimenter. Here we have a row for each one of our training sets, and down below we have also a row for each one of our training sets. Here we have a column for each one of our settings, and down here we have a column for each one of our settings. And the cell, the cell that you see has the performance value on training set 1 when exponent is 1. What do I get in a cross-validation? I get 61.12. On fold 3, when I use exponent 2 and I do a cross-validation, I get 63.45. So I fill in this table that you see from the table that I get in the experimenter. That should be really easy. Then for every row, I look to see which one of these numbers is the biggest number, and that's going to be 3. Now I've done everything I can do in the experimenter, and the next step I'm going to have to do in the Explorer. So with the Explorer, I'm going to compute the test set performance for each fold separately. So let's say for fold 1, I go to the preprocess tab and I load training set 1. Then I go to the classify tab, I load in SMO, and I configure the exponent with the optimal setting for fold 1 that I just computed in the table that I just showed you. Then I'm going to load a supplied test set, you can see. And what I'm going to do is pick the corresponding test set for the folds, so test set 1. And then what I'm going to do is run the experiment by clicking on Start. And then when I look at my performance value, I see what the test set performance is for fold 1, and I fill that in the table. Now I can do that for all 5 folds, then I can average over these to get the stage 3 average. Now let's say I want to compare that to what would I get with my baseline performance. what I can do for every fold, instead of using the optimal setting, I can use the default setting, which is 1. So I can compute another column of test set performances that way. And now I can do a comparison. I can compare the test set average for stage 3 with the test set average for the default setting. And if the stage 3 average is significantly higher, then it was worth it to do the tuning, otherwise not. And that is how you're going to do assignment 4.